All right, another day, another machined part. Today we're going to do the Toby 24-11-04 book stand. It's a tier 4, so I think it's going to be a little tricky. Yeah, and let's just hop right in. I'm going to get the music going. A little bit of a Salisbury Hill radio. It's a banger. And let's get rolling. Holy moly, we got a lot going on here. I can already tell that, let me turn this down a little bit. I can already tell that I'm gonna do a sketch on this plane, and we'll extrude the full width, and then we'll do extrude cutouts for that. We'll also do extrude cutouts for the circles and add the fillets for the rims. And then I'm assuming these are just cylinders that we extrude through the hole that's created. Honestly, I don't think this will be too bad. A lot of dimensions to figure out, but I think if you get the sketch right, a lot of it's pretty easy to do. What are these one and exact mirror part of part 1? Okay. That is interesting in terms of creating this. I hadn't thought about how I'm going to mirror it. So we know the distance here is, I don't know what 180 rods means. Oh, the rods are 180, there's 2 of them. Got it, it's 180 wide. So theoretically, if I were to do this on the this plane, which I think is the ZX plane, XZ plane, then I would need to create an offset plane to mirror from, and that would be 90 away, and then I could just mirror, and that would allow me to only worry about creating this once. So I think I am going to I'm going to start on the origin for this first piece, and then we'll mirror with an offset plane. All right, let's do it. So I'm just going to do the rough shape first, and then we can kind of think about how we're going to fill in the different pieces. So we've got 9° there. That goes up some distance. And it looks like it arcs. And we learned from that one video that the center point arc no, that's not what we want. What was the one that we learned recently? Maybe it's 3-point arc. Yeah, I think that's going to be a painful road if I to go down that road. I don't know. Like, clearly we want that to be maybe I just do a fillet. Does that make sense? Let's do that. So it goes over some distance, comes down. And then it's an arc of some kind. Oh, that's what I was looking for earlier. All right, let's go back. Let's go back. Oh no. So that was what we wanted, was a tangent arc. Yeah. We'll figure out the distance later. And then bring this, what the hell? Oh, that's the center point for the arc, okay. And then we bring this down. I think theoretically we could do another tangent arc. Okay. And then that goes up. And I'll just do that with fillets. I'll do this. I didn't actually hit that dot. There we go. Yeah, I'll do these with fillets. I might regret these two I did, but we'll figure that out. So let's just start measuring some stuff. This is 185 across here. Make sure we're in millimeters. Oh boy, this stuff was a lot. Oh no. Why is this so hard? Whew. I don't know why that had to be so hard. But that was painful. Okay. Let's do the height here, which is 220. And then I assume it's not going to give me a width here because it's going to be a function of basically all of these curves. So let's do that. So this one is 20. this distance here to here, it's saying is 50. Let's set this radius right. It's R39. I think that'll help. You also know the angle this is supposed to be, which is 17 degrees. I think I do that by selecting these two. Where is it? It's measuring from, it measures this from, I suppose, the axis. There we go. It's clear to me that this isn't tangent, so I can't fix all this wonkiness just by simply, oh, it literally says not tangent, but it doesn't say that here. So I guess it is tangent there, so let's do that. That'll make it easier. Now I can adjust this and yeah. It's like this can go anywhere I want. Huh. All right, let's set this radius. This radius is 22. And I'm pretty sure this and this are perpendicular. Which is not going to let me do. I'm assuming these are tangent then if it's not saying they're not tangent. Oh, that's constraint's already been applied. Okay. To virtual sharp. Oh, so there is a distance for that. All right, we also know that this, you know what? I set this thing to 20, but I actually don't think that's right. Or no, I didn't set it. I set the top of the arc to 50. Okay, but we definitely need to set the bottom of this. I have no idea how to do that. How to get the bottommost point. I mean, I kind of do. Let's get a construction line. And we'll do that. It's saying that's 20. Something's not adding up with this section here. It is being a pain in my rear. I'm just thinking, well, we're pretty confident that we got the top of the arc set to 50, right? So let's just go ahead and zoom in here a little bit. Let's get rid of that. There we go. So we just need this line and, oops. We need this line to be horizontal, I imagine. So I could set a constraint to be vertical. Now where does that put this? It could basically go anywhere. So what is constraining? I guess the constraint here is that the constraint here is that these are tangent. I hope I can do that at the very least. Or perpendicular. I don't want tangent. How do I enforce? Okay, we need to do some. Let me turn this down a little bit. Oh, there's a distance here of 22. That's where the constraint comes in. So this and this, oops, this and this is 22. Okay, now I think we're locked in. Yeah. Woo! That was fairly annoying. That was fairly annoying. All right, let's add some radiuses to this of 16. Okay. I think we're ready to extrude at this point. And we could do the circles real quick. I'll do that as a separate sketch. This thing is how thick are you? Okay. Let's do this little inset. I'm wondering if I can do like a offset from, because that's 8 offset. So let's get a sketch going. And I'll project all of these beautiful lines. And if we take these and we do an offset of -8. Here we go. I like it. And then we'll do a line connecting across. I think that connected. Yeah. And then this thing is 220 from the bottom. Sorry. Incorrect. 113. Now we can cut this. Oops. Actually, I don't want to trim. I want to break. We want to break. Oh, we broke that one too. Okay. So we can get rid of that. We can get rid of that. I think if we were to measure this, it would also be R8. We can verify. It's saying here's R8 4 places, so that's R8, R8, R8. I didn't actually set these to R8 explicitly. So if we measure it, yeah, it's an R8. Okay. So now what we'll do is add a couple fillets here. 8. And then last one. Okay. All right, we've got our little inset, and that is 12 deep. So we'll extrude that. is 12. And then it has some characteristics, it looks like. No? Well, maybe not. I don't know what this is. Oh, that's like a chamfer. Okay. 5mm chamfer. Could do that real quick. So let's get the holes going. I'll do another sketch for that. Oh, it actually says that 5 by 45 in 2 places. Okay. And it's saying that the midpoint of the hole is 78 from the bottom. What's this guy? It's also saying it is 40 from the back. I don't know if chamfered holes is a thing. I guess I better just finish sketch and double check. Countersink, I guess that's what that's called. Taper tapped. We don't want tapped. I mean, let's try that. I feel like I'm always struggling with where to put my holes because it's not latching on to this guy. Oh, okay. Remember, you just click. So we're gonna do 2. Select the back side. Yep. And then, does it tell us what the radius of this is? A 42 through hole. That's from the inside distance. Oh. What the heck just happened? Alright, let's try that again. So this is 42. This doesn't matter because it's a through hole. This is 45 with a 5mm. Or no, sorry, this is, oh, I keep undoing, and that closes the dialog. I think what I'm gonna realize is that it might be easier to do a chamfer and just do a through hole and then add the chamfer after. I think I'm gonna do that. I can see myself battling this for way too long. So we're gonna do distance to the back side, and we're gonna set it to a 42-inch hole. And we'll go ahead and just get rid of this sketch. Oh, but we needed the sketch for a hole. All right, fine. And then let's add the chamfer. I'll do it in both places. And it says it's a 5mm. I actually don't know what that means. Does that mean like this distance is 5? I guess I could measure from here to here is 7mm. That sounds about right. A squared plus B squared equals C squared. I don't know, that doesn't quite look right, does it? It looks like a pretty thick chamfer. What if I set distance and angle? There we go. I know, I feel like that's probably it. Let me just edit feature one more time, double check that looks right. We're doing distance and angle, and the distance is the distance of the chamfer, not the distance from I don't know if Fusion supports whatever this way of doing chamfers is, but if it's 45 degrees, we could do some math here, which seems insane, but break out my trigonometry real quick. I think it's measuring the distance of the hypotenuse. So a squared plus a squared equals, 5 squared plus 5 squared equals x squared. So if we do the square root of 50, 50 to the 1/2 is 7.0717. feel like that made it bigger. Wait a second. Do I not know how to do math? Now that distance is 10 millimeters. Oh, I was off by like an order of magnitude. But my 7071 did translate to an even number of. Wait a second. I'm so confused at this point. I'm really confused at this point. I'm gonna do a quick Google. Basically, I want to do fusion chamfer length of side, not chamferage. I don't know. I don't know the terminology. I'm gonna go for this, and then we'll measure at the end, and if I don't hit it, then we'll know it's probably that. What else can I do, right? So let's get these final two circles done. I'll do that with another sketch. Diameter. You know, it's much easier for me to put the diameter in when I'm making it. Did I say 50 or 15? 15. They are 50 apart, and they're horizontal to one another, so let's go ahead and fix that. And the distance apart is 50. The distance from the bottom is 20. Just got to get the other distance, 40. I was looking at the wrong one. What is the distance from center point to the center? Okay, so that's 25. All right. can just extrude these through. Just do all. Let's go back to this sketch and extrude. This guy. And do all. Okay. All right, so back to what we were saying before. If I do an offset plane of 90 from this edge, okay, now we can mirror this whole thing across that plane. Great. And then we are going to then I'm going to create a new component for this. Theoretically, these should have been new components, but they're the same density, so it's not as important. So let's create a new component. Oh, let's select this guy and then new component. Call it rods. I can rename this. I'll do it later. Okay, so now we're just going to create a couple cylinders through the holes, which shouldn't be too bad. In fact, I think what's the best way to do this? We can say 2. Oh. Let's try that again. And we're going to say distance to object perfect. We'll do that again. We're here. Distance to object. Wow. I think we've done it. So I'm gonna need to add a few new materials. Red oak. So let's add this to my favorites. And then also alloy. We'll just grab one of these. And then we'll duplicate you, rename you to 1060 alum alloy. TTT. I saw someone else use TTT. I think that's pretty smart. I'm going to just go ahead and do these two. And then we also have the red oak that we're going to duplicate. And we're going to rename to red oak TTT. This, and it's going to be, it's already 27, perfect. And then the red oak is 570. I can never tell canceling actually undoes. No, it doesn't. Okay. All right. Now let's set some of these up. Our favorites. We got red oak here, red oak here, and some alum alloy here, some alum alloy here. Okay. I've never done a multi-part thing like this, so I guess I just have to get the weight of both and add them all together. So let's go ahead and do that. So this one is 518, 502, and then this one is 171, 767. All right, so let's try and add those together. 518.502 plus 171.767. That gives us 690.269. Here we go. Hey, first try again. So all that dumb work I was doing around those chamfers was for nothing. It was measuring the length of, I guess I need to figure out what that I guess, yeah. The chamfer is measuring, the millimeters you provide of fusion is the distance, the perpendicular distance of the edges. From the point, not the hypotenuse. All right, that one's a little low energy. I think maybe it was the music, I don't know. But we got it, everyone. Everyone is probably, you gotta wake up. I think you're sleeping. You gotta wake up. We did it. But yeah, I'm gonna call it a video. Now what I'm gonna try and do is use a automation tool I created that will just giving the tjohnell Toby practice page and a Loom link. I'm hoping it'll just go up to YouTube automatically. So we're gonna try that out right now.